Alright class, welcome to Math 2020 review for the test 3, day 2, where I'm going to explain a couple of the problems here, show how to demonstrate how to do them. The first one we have is number 3. Number 3 says to draw and measure to the nearest millimeter the 3 altitudes of the triangle. Now altitude is another word for height. Okay? And so in order to find the height of a triangle, you need to establish a base. So I'm going to start with the triangle oriented in this direction. And this direction has a base. The triangle's base is this side here. And I'm going to do actually in blue. Okay, because I'm going to use different colors for the other bases. This is the first base, base 1 I'll call it. And in order to get base 2, you need to find the altitude. So I'm going to use my ruler here, put the altitude here, where it's a 90-degree angle from the base, from the bottom to the top. Okay, and I'll mark that off, 90 degrees. Okay, now this is the height. Height 1. Now what I'm going to do is I'm going to measure them, and I have measured them all previously, so I'm going to just show what those measurements are. And you can use millimeters or centimeters. I'm going to use centimeters, so that base 1 is going to be equal to 4 centimeters, and height 1 is going to equal 3.4 centimeters. Okay. So the area of the triangle with base 1 and height 1 is equal to 1/2 base 1 times height 1 is to 1/2 of 4 centimeters times 3.4 centimeters. And what you get is you get 6.8 centimeters squared. Okay, so there's one of them right here. Now we're going to do the finding the area. So I'm going to draw, I'm doing part A and B at the same time. So I found the area of the triangle with the base of 4 centimeters and the height of 3.4 centimeters. So now I'm going to rotate and find the area, find the base and the height of the triangle with this as the base here. So rotating. Okay, I'll put a little bit of a lock on here. Okay, so it doesn't move around. So rotating, and we use red now for this. This is my base right here. Base number 2. Height number 2, I'm going to get my ruler out. Okay, and place it right there. Draw my line. And this is going to be the altitude, or the height, from the distance from the bottom to the top. Here. That's height 2. So base 2 and height 2. Now these have measurements. Okay, so this base is 3.6 centimeters. And the height is going to be 3.8 centimeters. I'm going to rotate it back to straight to find the area part 2. Area of 2 is 1/2 of base 2 times height 2, which we know that 1/2 of base 2 was going to be 3.6 centimeters, and height number 2 is 3.8 centimeters. Now in theory, when I calculate this, the areas should be about the same, and indeed when I do, I get 6.75 centimeters squared. Okay, so why would they be a little bit off or a little bit different? Well, it's probably because of measurement error. My measurements weren't exactly correct. Alright, so now we're going to do a purple one, area of 3. I need to find half of base 3 times height 3. Oops. Okay, sorry about that. We're going to rotate my iPad again. This last part is the third base here. And then the height, grab my ruler, turn it to the perpendicular here. Okay, draw my line. Okay. Base 3 and height 3. Now base 3 is going to be equal to 4.5 centimeters. Oops, that's the height. And then the height is going to equal 3 centimeters. Okay, rotating my iPad back. Continuing our equation. Sorry about that. Oh, come on now. No, come on. Okay, just it's not writing, it thinks it's tapping. Come on, write. We'll do done for a second and then come back here. Might help. Kind of reset it a little bit. Okay, so we just need to continue on here. We have 1/2 base 3 was 4.5 centimeters. Height 3 was 3 centimeters. And then when we're done, we get to 6.84 centimeters squared. Okay, so there's that last one. All right, so that's how you do number 3. The area is 3 different ways. And we got about the same answer, so looks like it's good. Now we're moving on to number 20, which you need to find the missing length. Now all of these have x, and they are all right triangles, so we will be able to use the Pythagorean theorem. Oops, let's turn on our marker. Alright, so Pythagorean theorem says that in the right triangle, the square of the bases, sum of the square of the bases is the area of the square of the hypotenuse. So we'll do, that was the verbal way. Here's the algebraic way. A squared plus b squared equals c squared. So that's what we'll use throughout here. Now we're going to say that the hypotenuse has to be c, so we have to do 12 squared plus 9 squared is equal to x squared. 12 squared is 144. 9 squared is 81. That equals x squared. 225 is equal to x squared, which means that x is going to equal 15. On the next one, we have 6 and 3. So we're going to use the Pythagorean theorem the same way. 6 cubed plus 3 cubed equals x, sorry, not cubed, squared. Equals x squared. That's 36 plus 9 plus x squared. X squared is going to then equal 45. X is going to equal square root of 45, which you can separate, okay? Separate that into 9 times 5. So x is equal to the square root of 9 times the square root of 5 equals 3 square root of 5. The next one is 12 and 13. Now 13 is the hypotenuse, so we have to do 12 squared plus x squared equals 13 squared. 12 squared is 144 plus x squared equals 169, which is what 13 squared is. We subtract 144 from both sides, and our answer is going to go up here. 9 minus 4 is 5. 6 minus 4 is 2. So we have 25 equals x squared. Okay, so that means that x is going to equal 5. Now we have two more here. We need to find h in this first one. So we have our clues. 16 inches is the whole base of the triangle. The height we don't know. And we have it's an isosceles triangle. So there's two sides that are 10 inches long. So we want to do a right triangle. So this is isosceles, so I'm going to outline the right triangle here. Red. Okay, we're going to find you can find h by thinking about this red triangle as a right triangle. Okay. So this could be A. This could be B. It's not 16 inches, it's going to be 8 inches because we have half the triangle. That's it. The hypotenuse I labeled as A, so let's make that correction here. That should be C. Hypotenuse is always going to be by itself. C in that one. So what we have here is height of each. All right. So we have a squared plus b squared equals c squared. A lot of times I like to write down the formula so that we can know which part goes where. So a was going to be h because b was 8 inches. So c is 10 inches. So h squared plus 64 inches squared equals 100 inches squared. So I'm going to subtract 64 inches squared from both sides. Now h squared is going to equal 10 minus 4 is 6, 11 minus 6 is 3. Okay, h squared is equal to 36, therefore h is going to equal to the square root of 36, which is equal to 6. Okay. Next one is an isosceles triangle that is right. So we can deduce that that because this angle is right here, that this and this are the same. It means that we have a 45, 45, 90 triangle here. And in a 45, 45, 90 triangle, we have a shortcut to go from, to identify the lengths of all of the sides. Of a triangle. Put that up here as a note. Okay. Now if the isosceles triangle, if the triangle is isosceles, then x must equal 4 the other side, right? Okay. And that's by the definition of an isosceles triangle. What is y? Well, we want to go from here to here, so we're going to multiply by square root 2. It's a little bit longer, so we'll multiply by square root 2. Now, since there's not much to do with the square root of 2, we'll just go ahead and accept that as our answer, that y is equal to 4 square root 2. And then we got it. Okay, here's a few more. We have 9 square root 2 as the side of a 45, 45, 90 triangle. And what is going to x? So you multiply by square root 2. Oops. Okay, so 9 square root 2, x is equal to 9 square root of 2 times the square root of 2, which is equal to 9 times square root of 4, which is equal to 9 times 2, which is equal to 18. Next, we have 3 times the square root of 3. As one side of the right triangle, there's a 30-degree sign there, so we can deduce that it's 60 degrees. Because both two angles of a 90-degree right angle are added to 90 as well. And since we have a 30, 60, 90 triangle, we need to get x and y. So I take my long leg and divide it by square root 2, 3, to get the short leg. Come back over here, multiply that by 2 to get the long leg, the hypotenuse. This is 26. Okay. So numerically speaking, we start with 13 square root 3 multiplied by the square root divided by the square root of 3 equals x. Then we do 13 equals x, and then multiply that by 2 to get y. Okay, so y is equal to 26, where 26 is equal to y. And then this one, we have 30 degrees here, so we can deduce that this is 60 degrees. And we have 7 as the short leg, and you go up to the long leg. So 7 will now become 7 times the square root of 3. Okay. The hypotenuse x is going to be twice the short leg. So if the short leg is 7, the hypotenuse is twice that. Twice 7 is equal to 14. Okay. And that will be our answer. Okay. So let me know if you guys have any questions. Hope you enjoyed the video.